Every human being lives inside time. We wake within it, move through it, and eventually leave it behind. Yet despite its constant presence, few things are more difficult to understand. We speak of time as though it were obvious. We save time, waste time, measure time, and fear running out of it. But the familiarity of a thing does not guarantee that we understand it. At first glance, time appears simple. The past lies behind us, the future lies ahead, and the present is where life unfolds. This picture feels so natural that we rarely question it. But many of the most profound discoveries in history began with questioning what seemed obvious. The Earth appeared motionless until astronomers proved otherwise. Time may be another example of a reality that looks very different beneath the surface. The past appears settled. The future appears uncertain. The present feels immediate and real. This understanding is so familiar that most of us rarely pause to examine it. We schedule appointments, celebrate birthdays, and mark the passing of years. Everyday life assumes that time moves steadily forward, carrying us from one moment to the next. The idea feels so natural that questioning it can seem almost unnecessary. Yet many of history's greatest discoveries began with questioning what appeared obvious. The Earth seemed motionless until astronomers demonstrated otherwise. Space appeared empty until science revealed a universe filled with invisible forces and hidden structures. Time may belong to the same category. What appears simple from within human experience may be far more complicated when examined closely. Before we can understand what time is, we must first recognize how much we take it for granted. Long before mechanical clocks existed, human beings looked to the sky. The rising sun, the changing seasons, and the motion of the stars provided reliable patterns that could be observed and predicted. These cycles became humanity's first great timekeepers. Ancient civilizations organized their lives around celestial rhythms. Farmers depended upon seasonal changes. Sailors navigated by the stars, while priests and astronomers tracked the heavens with remarkable care. Across different cultures, the sky became both calendar and clock. Massive monuments were aligned with solar events. Complex systems were developed to measure years, months, and days with increasing precision. To many ancient observers, time seemed inseparable from the orderly motions of nature. The heavens moved according to recognizable patterns, creating the impression that the universe itself operated like a vast cosmic clock. By studying those patterns, people believed they were learning something fundamental about reality. Yet a puzzle remained. The stars returned to familiar positions. The seasons repeated themselves. Human lives, however, did not seem to follow the same cycle. For centuries, philosophers wrestled with this mystery. Some argued that time flows like a river. Others suggested that flow might be an illusion created by the human mind. One of the most famous reflections came from Augustine. He observed that everyone thinks they know what time is until they are asked to explain it. The moment we try to define it, certainty begins to disappear. Perhaps the difficulty arises because time is not an object. We can point to a mountain or a tree. We cannot point to time itself. What exactly are clocks measuring? A clock's hands move. A pendulum swings. An atomic clock tracks vibrations within atoms. These devices measure change with extraordinary precision, but are they measuring time itself or merely the processes that occur within it? This question becomes even more interesting when we turn to science. For a long time, many believed that time flowed identically everywhere in the universe. 1 second on Earth was assumed to be the same as 1 second anywhere else. Then came a revolutionary discovery. Albert Einstein showed that time is not separate from the universe. It is woven together with space into a single fabric known as spacetime. This idea transformed our understanding of reality. Time was no longer a universal stage upon which events occurred. It became part of the structure of the universe itself. According to relativity, time does not pass at exactly the same rate for everyone. Motion and gravity can alter the passage of time. Two observers following different paths may experience different amounts of time between the same events. This is not science fiction. The effect has been measured repeatedly and must even be accounted for in modern satellite navigation systems. Time truly behaves differently under different conditions. The implications are astonishing. If time can stretch and contract, then it is not the fixed and universal quantity we once imagined. Something far stranger is taking place beneath everyday experience. There is also the question of why time appears to have a direction. The laws of physics often work equally well forward and backward. Yet everyday reality clearly distinguishes between past and future. One proposed answer involves entropy. Entropy is often described as the tendency of systems to move from order toward disorder. As entropy increases, the distinction between before and after becomes more pronounced. This idea helps explain many familiar experiences. Eggs break but do not spontaneously unbreak. Smoke disperses but does not gather itself back into a candle. Entropy may help explain why the arrow of time points in one direction. But even this raises further questions. Why did the universe begin in such a low entropy state that a direction could emerge at all? Relativity also challenges another assumption. We naturally believe that the present moment is uniquely real. Yet some interpretations of physics suggest that past, present, and future may all exist within spacetime. This idea is often called the block universe. In this view, time does not flow. Instead, all moments exist together, while consciousness experiences them one at a time. Imagine a book. Every page exists simultaneously, yet the reader encounters them sequentially. The sensation of movement through the story arises from the reader's perspective rather than from the book itself. If this picture is correct, many familiar ideas change dramatically. The distinction between past and future becomes less absolute. Reality resembles a landscape more than a river. Not everyone accepts the idea that all moments already exist. Many philosophers argue that the future is fundamentally different from the past. The past contains completed events, while the future contains possibilities that have not yet become reality. According to this perspective, tomorrow does not already exist somewhere within the structure of the universe. Reality unfolds moment by moment. New facts come into existence as events occur. This view preserves an intuition shared by many people. When we think about the future, we often experience it as open rather than fixed. Plans can change, decisions can alter outcomes, and unexpected events can redirect entire lives. Supporters of the open future view argue that possibility is a genuine feature of reality. The future is not a hidden destination waiting to be discovered. It is a landscape that is still taking shape. If this perspective is correct, some of our deepest questions take on a different meaning. Knowledge of the future, freedom of choice, and the nature of possibility become intertwined. Understanding time may require understanding how potential becomes reality. Whatever physics ultimately reveals, human experience presents another mystery. We do not simply observe time. We seem to live within a moving present that constantly carries experience from anticipation into memory. The present moment feels uniquely important. The past can be remembered, and the future can be imagined, but only the present appears directly accessible. Every experience unfolds within the present moment. Yet science has struggled to explain why the present feels special. Physical equations often describe events without assigning any privileged status to the current moment. The universe described by mathematics can appear very different from the universe we experience. This raises a profound question. Is the sensation of temporal flow built into reality itself, or does it arise from the way conscious minds process information? The answer remains uncertain. Memory allows us to retain traces of what has already happened. Expectation allows us to imagine what may happen next. Between these two horizons lies the living experience of the present. Perhaps the mystery of time cannot be solved by physics alone. Perhaps understanding time will ultimately require a deeper understanding of consciousness itself. The investigation that began with clocks and calendars may eventually lead inward, toward the nature of awareness. The deeper we investigate time, the more mysterious it becomes. What seemed at first to be a simple backdrop to existence reveals layers of complexity. Every answer opens new questions. Perhaps time is a physical dimension. Perhaps it is an emergent feature of a deeper reality. Perhaps our understanding remains incomplete in ways we have not yet imagined. What is certain is that time shapes every aspect of human life. Our memories, hopes, fears, relationships, and ambitions all depend upon it. To understand time is, in some sense, to understand ourselves. And yet the central mystery remains. Does time truly flow, or do we merely experience it as flowing? Is the future already there, or is reality still being written? The more carefully we examine time, the less obvious it becomes. What began as one of the most familiar features of existence transforms into one of its greatest mysteries. Perhaps the deepest lesson is not that we have solved the problem of time. Perhaps it is that we have only begun to understand how strange it really is. Time began as a question about clocks and calendars. It became a question about reality. And perhaps, in the end, it becomes a question about ourselves. Join us next time as we explore one of the deepest mysteries of all. Do we have free will?